Hi, and welcome to this 7th clip in the Organic Chemistry series, and in this one we're going to look now at the alkene family of compounds. And in the previous clip we showed how alkenes can be formed from longer chain alkanes, and in the preceding one we looked at the formation of ethene as the primary product of what we produced in there. And if we were following our naming conventions as we've been using for the alkanes, we can see that the eth part at the start of the name comes from the presence of 2 carbons, and we have now introduced this new ending of the word, the ene part, indicating the presence of this double bond motif here in the center of this compound. And this makes the compound different in its chemical reactivity in comparison to the same length carbon chain for the alkane, this one being eth again because it's got 2 carbons, and this time with the ane ending. And so if you remember again from previous examples, the alkanes are saturated hydrocarbons because each of the bonds are singles, and each carbon is bonded to the maximum number of other atoms, whereas in this alkene we now have an unsaturated situation, and this double bond, this carbon-to-carbon double bond, which is an area of high concentration of electrons, is able to react in different ways. So the alkanes are typically just used as fuels. The alkenes can also be used as fuels, but the presence of that double bond gives them different chemical reactivities. And in future clips we'll look at polymerization and things like that. But we can see that if we were to also draw the next one along, so we would this time go to pro, which is 3 carbons, propene. So again we've got this ending of the word indicating the presence of the double bond, and then we fill up the valence shell of carbon. So we know that carbon has 4 bonds in each case, and so we have to be careful this time to show that when we draw the alkene, which in this case is a C3H6 formula as opposed to the C2H4 formula previously, we can see that we have essentially an open space here where there used to be a hydrogen, and likewise here. And it's this ability to add in additional elements and additional compounds in here which gives these alkenes their reactive chemistry. We will look at it in more detail in a future clip, but as we say, this double bond can then undergo addition reactions to create, primarily for the purposes of GCSE, addition polymers. However, one important reaction that we can do with this double bond is the addition of bromine to the compound. And so one good reaction that we can show here is ethene reacting with a bromine molecule. Now you would come back to this molecule reaction at A level and look at it in a little bit more detail, but bromine is an orange liquid. You may use it as bromine water for this specific example to reduce the hazards of using neat bromine, but ultimately bromine is an orange or light brown solution. And if we were to react the bromine with our alkene, in this example ethene, then as we said just earlier, it is possible for the double bond to react with another molecule. And in this case, what it does is it takes that bromine, the Br2 molecule, it splits it in half, and it allows the creation of, or the recreation of, the 4th bond to each of those carbons. And so carbon again has created itself as a saturated molecule, so it's now again bonded to the correct number of carbons, or the maximum number of atoms, should I say, in this case 4. But we've gone from the alkene and the presence of the orange to this new compound, which is a bromoalkane, but importantly, here, this is colourless. And this change from orange to colourless is regarded as a test for the presence of a double bond. And so if we have a double bond and we add bromine water to it, what it is said to do is decolorize the bromine water. And if we see decolorization of bromine water from orange to colourless, we know we have a positive test for the presence of a double bond. And so we know we have an unsaturated molecule, and in the purposes of what we are doing today, we know we have an alkene. And we can then proceed in its reactions. And so what we'll do in the next clip is we will look at this reaction, which is, as I said, an addition reaction, but we'll look at another couple of addition reactions which will give us ways of creating other compounds such as alcohols and polymers. Polymers, very useful in the plastics industry, in the manufacture of polythenes and PVC and polyvinyl chlorides and polystyrene and other such polymers as we need in the modern world today. So, thank you for this one. A relatively short clip this time on alkenes, but we will proceed in the next one to reactions of alkenes, and I will see you in that one.